to conferences all the time is the main driver for progress in your skill set and also your relationship. And basically, any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, and you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi folks, this is Nicolas Frankel. I'm a developer advocate at Hazelcast, and at TestCon Europe 2020 I will be talking about a subject that is dear to my heart, the subject of testing. But not every kind of testing, because there are many different kinds of testing, but how do you assert that your test's coverage is relevant, that your tests are actually testing something? And how do you measure that? And some people tell you that, you should have 100% code coverage, and they make it a rule because they're applying TDD, and first you write the test and then you write the code. But actually, if you don't want to apply TDD and you don't want to have 100% code coverage, what would be a good number? And if the number that your code coverage gives you, can you trust it? And I will show you that in some cases, 100% is not enough. 100% means nothing. And in most of the cases, 100% is too much. We don't need that much. So please join me at TestCon Europe 2020. Hi folks, thanks to be here for this talk about mutation testing. I'm Nicolas Frankel. I've been a developer, I've been a team lead, I've been an architect. I've held different technical roles in my career, and since 2 years, I'm a developer advocate. However, in all those roles, I've always been interested about code quality. Right now, I work for a company called Hazelcast, and Hazelcast has 2 products. The first one is an in-memory data grid, and you can think about an in-memory data grid as distributed data structures. So if you have a map or a hash or a dictionary, depending on how you call it in your language stack, then you can shard it so that not all the data is on the same node. You can distribute it over the network, or you can replicate so you don't lose data if one node switches off, this kind of thing. And the other product is called Hazelcast Jet, and Hazelcast Jet leverages IMDG to offer you very fast in-memory stream processing. Today, I won't talk about either of them. I will talk about testing. And since it's a testing conference, I assume you're interested in testing. And I also assume that you know about different kinds of testing. As developers in general, as junior, you start by writing unit tests, and perhaps you become interested in testing more of the software that you deliver. So you delve into the realm of integration testing. And if you are a software engineer in test, then perhaps you do end-to-end testing. And if you are in the realm of performance, then you do performance testing. And if you are a security white hat then perhaps you do penetration testing to help your customer. Well, there are a lot of different kinds of testing. And at one point, I stumbled upon an article that listed nearly like 100 different kinds of testing. But every one of them, they have only one goal, and their goal is to ensure the quality of the production code. So basically, everything is my code fit for production? So in the case of performance testing, for example, yes, it will handle the loads. In the case of penetration testing, yeah, there are no found security issues, and so on and so forth. The problem is, how do you check the quality of the testing code? Well, everybody knows you have this stuff called code coverage. And if you go on the wiki page of code coverage, you have this definition: the measure used to describe the degree to which the source code of a program is tested. How does it work? Well, when you execute your tests, you will just mark that a source code line has been executed. Or you can also not do it on the line, but on a branch, because branch can go one way or the other way. And then you have this very hard formula. You have the number of lines that have been marked, that have been executed. You divide it by the number of lines total, and you multiply by 100. And it gives you your percentage of code coverage. In the Java world, there are a lot of tools that allow you to do code coverage. Right now, the most popular is Jacoco. When I was a bit younger, Clover was also quite used, Cobertura as well. But in all cases, now you've got your code coverage. That's the end of the talk. We know how much our tests are valid. But the new question is, what is the good code coverage? What goal shall we achieve? Is 100% code coverage like normal goal? And some people in the industry are saying, of course, this is realistic. I mean, that's the only code coverage you should aim for is 100%. Because if you write a line of code, you can write one test for it. And yeah, it makes some sense, especially if you practice TDD, since you are writing your tests before you write your code, then in the end, you will achieve 100% code coverage. If you don't practice TD, but you will write your test afterwards, and then you will get your 100% code coverage anyway. But I disagree with that approach. The first is, in the end, at the end of the project, you might not want to deliver the test. You deliver the production code. So if you have a lot of tests and the production code has not been written, it doesn't work that well. So 100% code coverage, we know that in most cases it's like over quality. At some point, you must, we are engineers, so you must balance the trade-off between the high quality and delivering the project. And there is another issue here. Let me show you the snippet. And if you execute these tests, you will see that you will have 100% code coverage. The thing is, we just forgot about the asserts. But, as long as the code coverage is okay, that's fine. Or not. So, having this code coverage as a measure of quality of the codes is, in my opinion, a very, very bad idea. I mean, code coverage is a metric, and every metric can be gamed, and this one can be gamed very, very easily, as I've shown you. You just omit the assert and everything is fine. The worst case is you might say, okay, but we are not gaming because we are good developers. And I believe you, you are good developers. I'm a good developer as well. But you might have tests that are not that good, not on purpose, but by accident, because you just forgot something. I would go as far as saying that in some cases, in some contexts, a high cut coverage is a bad thing, because then you have this sense of security that you have low cut coverage, you will refactor your code and you will be very, very cautious. You will check, do every test, then run your code in a specific environment to check that you didn't introduce any regression. With a high cut coverage, however, you might say, oh, I did my refactor, all my tests are green, I have 100% cut coverage, I send it to production, and then boom, it doesn't work anymore. So the problem still stands. If cut coverage cannot ensure the quality of your tests, what can we do? And I'm not here to tell you about a problem and then to just go away. I will propose you to use mutation testing. So let's illustrate how it works. You might remember the X-Men movie. Now it's a bit old, and I will use the same cast as in the movie. So you have this guy called William Stryker, and in my example, it will be the original source code. And then I have his son, who is a mutant in the movie, and in my example, it will just be the source code that has been slightly modified. So for example, I have this stupid math class, and this is Java code, but basically I believe this is simple enough that, I mean, if you are doing JavaScript or C# or whatever, it should be the same. So I have this math class and I have this add method, and then I add the two parameters. I mean, very, very stupid. It's just an example. So how do I create my mutant? I will replace the plus by a minus. And in standard testing, you execute the original source code. It gives you green. Everything is fine. In mutation testing, you will create this mutant and you will execute the exact same tests. And there are two outcomes. Either the tests fails and we say that basically we have killed the mutant, or the tests like succeeds and the mutant is said as having survived. Now think about it. If a mutant survives, that means that we change the source code and the tests still pass, which is not a great thing, meaning that whatever our test tested, changing the source code didn't change the outcome of the test. So it's bad. And killing, on the opposite, means, yes, now the test fails, so basically our test is relevant. So it's the opposite of the movie. In mutation testing, we must kill mutants. We must kill all mutants. So let's redo the same stuff by having the codes in front of us. I have always the same math class. I have forgotten the assert. I execute the test. Of course, it works. I create the mutants with the minus instead of the plus. And yes, here it's still green, mutant survives, it's bad. Now I've added the assert, and of course, since I'm asserting that 1 + 1 = 2, it works, that's fine. And now if I create my mutant and I execute the same test, of course it fails. So this is how you can detect that your test is relevant, that you're actually testing something. How to do it? Well, I will talk about my normal technology stack, Java, but at the end of the talk, I have a reference, so you can also use it in your tech stack as well. In Java, there is a tool called Pit, which is available as a command line tool or as an end target, but most probably you will use it as a Maven plugin. How does it work? Well, it has some patterns called mutators, and patterns will be applied to source code to produce mutants. So for example, you have here some sample of mutators. There are a lot more, but it will search for this pattern, for example, for higher than, and to create a mutant, it will replace higher than by higher or equal. Or it will check for equal and replace it by not equals. It can also do strange stuff, such as like changing the value of constants or changing the return value. It can also remove void method calls or assign nulls to objects. There are some important mutators. The first one that I need to mention is the conditional boundary. I don't know how long you've been a developer, or a tester, but my experience has shown me that if you have such a boundary, in general, you test above the boundary and you test below the boundary, and you forget to test the boundary. And every time the bug is hiding there. So having this mutator that will change the boundary is of great help. Another mutator that I really think is worthwhile is this void method call. There is a high chance that they are not tested in your code. This assert check not null, for example, there is no tests. In general, I might be wrong, but in general, in my experience, I've never seen them that test that if you pass a null parameter, then it will fail. It's not an issue when you write the code, it's not an issue when you execute the code, but in general, what happens is that somebody will remove the assert because you need to refactor your code, you need to pass null at whatever point, and afterwards, then the code that has been updated is not on par with the tests, and you might release a bug into production. Connection.closed, when you have a connection to the database, for example, you want to make sure that every time you close the connection to the database after you have used it. I've never seen it tested. And if you don't test the connection that is closed, then if you have a connection pool, or even if you don't have a connection pool, then the number of connection increase, and at some point the database, well, cannot handle more connections. So this is the kind of stuff that might seem not relevant to test, but that you need to test, and you need to make sure they are tested. Sometimes also your IDE generates code and you say, it generates code, so that's fine, we don't need to test it, and that's true. That's true until you need to change the entity. So you add more attributes, they need to be part of equals and hash codes, and you forget about it. And again, it might cause trouble. So I've talked a lot. Let's see some demo first. Here I've created this duplicate math class. Again, it's Java code. There is a math class in Java. This is just for the sake of demoing. And here I've created these tests. And as in my example on my slides, I've forgotten to have these asserts. So I run these assertless tests. And here it will tell me that everything is fine. I mean, the test passes. But here you can see there is 0% mutation testing. It's not enough. In general, we would like to have some reports. So I've created some reports. Pit by default generates an HTML report similar to JUnit. And here you see, hey, I have 100% code coverage. I'm a hero, but I have 0% mutation coverage. So I'm not that good. And if we check the duplicate math class, it tells you that, yeah, it replaced integer addition with subtraction and the mutant survived. Also, it changed the return with 0 and the mutant still survived. How do we kill the mutant? Well, just let's add the assert. So assert equals, and so it's 2 is sum. And let's run it again. And now we see that we've got 100% mutation coverage. And back to our reports, everything is green. So now the line coverage is equals to the mutation coverage. That's good. As I mentioned before, here I have on purpose omitted the asserts. You might be very good software engineers and you will never forget asserts. That's fine. Here, I have created another class that's called low-pass predicate. And low-pass predicate allows you to filter if what you pass as a parameter is below a definite limit. And here I have my tests. And I create my low-pass predicate, and I test below the limit, and I test above the limit. So let's run it. So I have all my asserts. I've done my job. That's fine. I'm happy. But still, I'm not 100%. Why is that? Because if we check the report, we can see that it changed the conditional boundary here, and the mutant survived because we forgot to test like at the boundary. And here it was not on purpose. It was just I forgot to do it. So when equal limits here, and I will say here it's a limit. And now if I run it again, now I'm finally at 100%, just to be sure. Check the report, everything is fine. And I'm happy having 100% mutation coverage in my report. Now let's try to do it on real-world projects. I have these Java Money projects, and if you are in a Java developer or working in the Java world, Java Money is to money what Java Time was to time. So it's basically an open source initiative to try to model money in the real world. So let's try to do mutation testing on this code base. I need to find the nodes. So first things first, I want to check how long it takes to do just the tests. So the normal unit tests, they take like a couple of seconds, 7 seconds. And let's try to do mutation testing now. So first lesson, it doesn't always work. Like for reasons I cannot fathom, here it tells me that the tests, some tests at least, they didn't work with normal unit testing, which is not the case because I proved you before that it worked. So, okay, I just need to remove those test big money and test currency unit and test money. So let's do it. I can exclude those tests from the run. And here, I will continue talking and talking because otherwise you will see that we will be there for some time. It's taking a long time. I will get back to it later. So, Pit is not perfect. There might be false positives. It's imperfect in some cases, and it's very slow. First thing, Pit is not able to understand that here it's all mutants have been killed. It will tell you that it changed the condition boundary and the mutant survives. So if you write code like that, which is perfectly fine, it will find a mutant, a surviving mutant, where it should have been killed. So not that great. You can, of course, change the way you write code, but it's not what you should do in every case. Now, if you have tests that do very bad stuff, if you have production codes that does bad stuff, but during your test you want to, for example, check that this method is called, and Pit will remove this method call because it's a void method call, and Pit it can do it. And so during your test, you will reboot your machine. That's probably not what you want. So in that case, it's better not to do mutation testing on this kind of tests. And finally, Pit is super slow. And every mutation testing framework is super slow. Why? Well, first it must analyze the test code, which is normal. But then for each class that is used in the tests, and for each mutator, it needs to create a mutation and run the test again. And then, of course, analyze the result and aggregate them. But that means that if you add a new test, it will create that many mutants for each class in this test. So you have this exponential creation of tests, and of course that takes a lot of time. Let's see if it has finished. No, it still hasn't finished. So let's see how to cope with these speeds problem. The easiest way is to set a limited set of mutators. So by default, you have a high number of mutators. You can add additional optional ones. You can add your own as well. But because every time you need to create mutants for all those mutators, then it might be a good idea to limit the number of mutators. So you can only have 2 or 3. Just think about it, that in that case, yes, it will be faster, but you will lose confidence in the results. Because if you remove conditional boundary, for example, and you forgot to test the boundary, then it doesn't work that good. Likewise, you can't limit the scope of target classes or tests, just as I did in my example. On Jodamoni, I removed some of the tests that didn't work. Again, it's faster, but then it removes confidence. You can also limit the dependency distance. The dependency distance is basically if your test uses class A and class A uses class B, then there is a dependency distance of 1 between the tests and class A, and 2 between the test and class B. And PITs will analyze every class that is used and will mutate it. And the idea behind the dependency distance is that the further you are from the tests, the less chances there will be an incidence to have a mutant there that that will survive despite the test. So you can limit the dependency distance. Again, it's a bit better, but it's not free. You might lose confidence. One easy way to do that is to increase the number of threads, because you are doing mutation testing on unit tests, and unit tests are supposed to be independent of each other. So if you increase the number of threads to the number, for example, of cores on your machine, then you will have an instant speed boost. Very, very important, you don't want to bind to the test phase. What I've shown you in my IDE is every time I called MVN tests, then I also executed this mutation testing stuff. It's not a good idea, meaning that you cannot run your tests without running mutation testing. That shouldn't be done, because you still want to have your tests that are run very, very fast to give you confidence as a developer. And perhaps you can run this mutation testing once every hour or whatever on the continuous integration server. So that you should never do. There are 2 other techniques that are smart. The first one is to use SCM mutation coverage. And SCM mutation coverage means that the classes and the tests that are not changed under the SCM, they will be run again and you will keep the same result. And you have the same with the incremental analysis. That means that when you run your test, it's not based on SCM that time, it's based on a hash. So the first time you run your mutation testing with incremental analysis, it will create a hash of the test and the classes. And basically, if the tests, neither the test nor the classes have been changed, then it will keep the results. Let's see if it has finished. Yes, here, nearly 4 minutes. So remember, it was 7 seconds with just normal tests, and here it's 4 minutes. So it's already quite a lot. And remember that we have removed 3 test classes. So let's see to use incremental analysis. Here I already did it before. And because nothing has changed, normally it should be very, very fast. Let's see. Here you can see will read and write history of blah, 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 blah. I hope it didn't change. Please. Yes. So it hasn't changed and it's like only 28 seconds. So this is something you should use all the time. And just remember to store, because you can decide where to store the history. You shouldn't put the history in a folder where it's removed, like in the target folder of your current projects, just because if you do a Maven clean, it will remove it. So it's not a great idea. Let's check the reports for this JODA money. So here, for example, you can see that the mutation coverage and the line coverage are quite similar, which is a good thing. However, if you break down, then you see that here the JODA money package has only 3% difference, but here you've got a lot of difference. So basically you have a high confidence because you have a high cut coverage, but the real confidence is this figure and it's not that great. So if we go like into this package, let's see where the difference is higher. Like here, for example, here you have like context 100%, but only 83%. Here, builder 100%, but only 77%. So probably here, here it's even worse. Money amount style 92%, but 65% of mutation testing. So probably if we check there, we will see a lot of stuff. So of course, here the constants, that is very usual. Here everything is green, and now we can start seeing the check not null that has not been tested. So basically there is no test that checks that if you send null, you will get an issue, an exception. And as you can see here, you've got all those like boundary tests. They are not tested. There is no test that does it. And this is a really, really bad issue. So at the end of the class, you will see, here, all the mutants that survive, and you can check here, for example, this has not been tested. As I mentioned, hash codes and equals in general, they are not tested. For good reasons, because the IDE generated it, but that means that this class now cannot change easily, or there will be lack of confidence that it still works as expected. So I hope I convince you that you need to use mutation testing in your project today or tomorrow. But is it the silver bullet? Because a lot of people say, hey, look, my solution is the best ever, you should do it, and forget about everything. Well, remember that mutation testing is only to check the relevance of your unit tests and to point out potential bugs. All the other tests, kind of tests you still need to do, like integration testing to check that the full application still works as expected, performance testing, security testing, everything. So it's just one additional step that you need to do. I would like to conclude also about return over investments. Like 10 years ago, I had to tell people, please, dear developer, check your code. Please write tests. I want to be sure that we have a reasonable degree of confidence in what's shipping to production. Sometimes, right now, I have to tell people, hey, these tests is not that good. It's nearly close to useless. And the reason for that is about this like 100% code coverage, because yeah, if you like follow some people, they will tell you, hey, do 100% code coverage. But remember that you don't do 100% code coverage to follow some leaders or to do because your boss asks or to have a higher code coverage than the other team. And you do it, your tests, only because you believe deeply that the time it takes to write a test now is less than the time you will spend by like having to debug a potential bug afterwards that could have been avoided by writing the tests. And since we are working in the real world with projects, with budgets, we cannot test everything. So we need to prioritize. And in order to prioritize, I would suggest you start with business critical codes and complex codes. And then if you've got time, of course, you can increase the code coverage up to a point where you are happy with it. But again, engineering and development is about making trade-offs. Thanks a lot for your attention. You can read my blog. You can follow me on Twitter. Here you can find the sources for the demo code that I've showed you. And if you are not working in the Java ecosystem and you still want to apply mutation testing, here is a repository called Awesome Mutation Testing, where you will find like tools for mutation testing in a lot of different language stacks, such as JavaScript or C# or whatever. So thanks again and see you. Bye.